So this time there's no doubt that you're sitting across the bench from me, and I can't help that. I suppose I could flip the camera or something, but it doesn't really matter. I'm here, and you, dear viewer, are over there. You know, like a partner's table. You know, a table designed to have someone sitting across from you and yet still be engaged. But a partner, law firm type partner. Anyway, we are doing resistor packs today. I'm pleased to say that all of the individual resistors on this board are done. And I've got autofocus on, which will be a bit sucky. But, you know, this is not a YouTube channel that has a whole lot of it's rough, and that's okay by me, and it's my YouTube channel. So what I have is this bill of materials that came with my parts kit, but which is available online. I noticed it was a bit incomplete here with the quarter watt resistors 4K7 and 10K. 4K7 I think needs to have 309 added to it, and 10K needs to have 242 and resistor 802 added to it. I've never used these before. These are a resistor pack, and they are literally a bunch of resistors in a pack. I've never used them before. It may still be I'm installing them the wrong way, but I don't think so. They are a block with, let's go with 4 legs. It's a pretty simple case, and we'll do another one. And inside there's either a resistor like this to each leg, so there's, you know, 10 ohms between there and there, and 10 ohms between there and there, and 10 ohms between there and there. And I think that's what's called bust, or they're individual. And that's what I think an isolated resistor is called. And then usually at one end of it there's a bunch of nonsense. On mine there's a beta and then there's a dot. And what I understand to be the case is that I need to match this up with the square on the board. And again, I've drawn this to suit me, but I'll spin it around for you. So if this is the resistor pack and there's a dot here, and there are 1, 2, 3, 4 legs, not that I've seen one with only 4 legs, I should add, and I suspect you just use discrete resistors for that. The pattern on the board look like that. 1, 2, 3, 4 holes, and this will be boxed up. I'm not guaranteeing you that this is right, and won't be able to until I turn this on, but that's how I understand it works. Now, I have also gotten into the habit, because I want to confirm the work of the seller, that these resistors are indeed what they say they are. So, maybe I can show you. It's a little bit sketchy, but maybe I can show you a photo that I took with my microscope of the dot. I don't know if that'll work. Yeah, it seems to be. It's all a little bit, how you doing? Anyway, this resistor here, the dot's over on this side. It's in frame? Yeah, it's in frame. And I've got my multimeter here. Now this is a resistor network 1K isolated 10 pin, which should mean that if I pop my multimeter into resistance mode, yep, you can see the multimeter, and touch between these first 2 pins, I should see 1000 ohms on the screen. 0.994 kilograms. And then if I touch the next leg, nothing. Nothing. If this was a bust one, each one of these would be 1 kilogram. Between the second leg and the thing, and the leg following it, nothing. But between legs as 1, 2, if I go between 3 and 4, 1 kilogram. So I'm satisfied that that resistor is what the package says it is. Now, so that's a 10 pin SIP, single inline package, isolated 1K. 1K isolated 10 pins. So that's resistor pack 802. So over here on my computer, oh man, this, as you can see, I've already done some, and the 10 pin isolate R802, and the reason I've waited till now to do a bit of recording is that it requires all of my concentration. Apparently this fellow is off to the left of the floppy drive connector. I should say too that I don't think for isolated ones polarity probably matters. I've not sat down and drawn it out and untangled it properly, but that seems right. But I'll put them in the right way anyway. RP802. So this fellow, oh no, see, talking, dot, square, and the square pad too. Oh no, it's getting away. I'm running for Prime Minister. Okay, in you go. And that looks right to me. And what I've been doing is canting them, tilting them, so that I leave myself as much space as I can if ever I need them. So if I just close this fellow here, I can check my framing again. That's not too bad. So these ones here, for example, I have canted them away from the edge connectors. These ones away from the edge connectors. And I found when soldering them, well, the common pin is often attached to an awful lot of copper and requires quite a bit of heat. But the that's me turning the soldering iron on. But the it actually matters to get a good consistent result to rotate the board, so the iron comes in and when it touches the leg it doesn't try and undo the work I've done to cant it. Now this one here, I think the further it is away from the floppy drive header the better. These sockets aren't going to be in the way, and it's just a lump of blue tack. Confirm pin 1, yep, 802. 802. I'm just going to have to check this. I really don't want to do any rework. 10 pin, 1K isolated, 802. And a plastic bag, and what I try to do is get these plastic bags and only have the one next to me that I'm working on. But I invariably stuff that up because I get carried away. Resistor network, 1K isolated 10 pin, only one in the pack. I've only got one of them, and so far that's the only one I've done where there has been only one of them. So I'm satisfied that's the right one in the right spot. Sorry about my head. So sorry about my head. Oh, it's a bad head. So that goes in there like that, and we will now flip the board. Now I'm right-handed, so we'll flip the board this way. And that's the resistor pack there. So I've got my iron set fairly hot. I find that not only do the connections with common require extra heat, but there's actually a fair bit of metal in these packs. That's my fan, you can hear. I'm only putting two only doing 2 pins. What I'm going to do is set up a big fan and actually have a draft blowing through my workshop, and I'm going to then go back and finish all the resistor packs. But for now, given it's foggy outside, I want to minimise the amount of smoke I make, even though this is a big space. And I've lost it. Sorry Glenn, I've lost it. That's one for the Australian viewers. Oh, here we go. Glen Ridge, Sale of the Century. You know, they press the button, dong, and then they just can't remember the answer. And the standard thing that the contestants will say, sorry Glenn, I've lost it. Glen Ridge. Alright, Tony Barber previously. Bit of heat in here, letting it run in and go. A little bit of solder. Solder helps conduct the heat. Look for it, wick away, and it's gone. A little bit too much solder on there in the end, which is my way, always has been. Here we go with the first pin. No, the last pin, I guess. Oh, the solder stuck to the leg. Come on, Flux, do your work. Yeah, these are a pest, but that's just how they roll. I turn my iron off, I've just about had enough. Stop, revive, survive. So that is a resistor pack, and I need to go back and do all the legs, which will be fine. I'm quite looking forward to and I'll be able to get the heat on the iron dialed in right and just go. And the same with these edge connectors. Even which I'm looking forward to, and then a friend's like, oh, they could be the hardest, and I'm like, nah, stop it. No, they'll be fine too. This is looking to be properly doable. It's not until I got to about here and have dealt with these, which I've never dealt with before, that it becomes sort of, I get to a point where I start to become confident that this is all very doable. This solder I'm using is, and I mentioned it before, Chipquick SMDSW 0.0314 ounces, no clean, water washable, 2.2% flux core solder wire, 0.8 millimeters in diameter, and it's 63% tin and 37% lead, which means that this is quite interesting solder. It, compared to the usual stuff, which is 60-40 and has what's called no clean flux. Now, no clean flux doesn't need to be cleaned off, but is hard to clean off, relatively. Wash-offable flux is easy to clean off, but has to be cleaned off, or it'll eat your board. This Chipquick stuff apparently is no clean and water washable. And they may have a patent on it. I think I read somewhere that it was only Chipquick that did this. And normally I use lead-free solder, but for rework purposes and for the fact that some of the connectors and stuff I'm going to be using will already have leaded solder on them, I decided just to go with it. The other thing with this is that being 6337 instead of 6040, this alloy should be properly eutectic. That is to say, it should have but one melting point. There should be no plastic phase in between it being liquid and solid. It was expensive, but the idea that I'll be able to get a moderately stiff brush, maybe a nail brush, or maybe I'll have a look on Element 14, put this in the laundry tub and scrub the flux off under hot running water, and then maybe rinse it with distilled water, and then I'll blow it out with compressed air, rather than having to try and deal with isopropyl alcohol and so on. The idea that I can do it like that is very exciting. Why is there still a lump of blue tack on this fellow? Did I miss him? No, I just didn't take the blue tack off him. So I'm pretty pleased with this stuff, save for the fact that it's full of heavy metals, and if I do a lot at once, I wear gloves too, otherwise I'm careful not to touch my face. Honestly, with heavy metals, paranoia is not misplaced. So these are the resistor packs going in. Once the resistor packs are done, I will probably move on to the capacitors, save for the electrolytics. They can go in last according to John Hertel's page, and they're quite sticky outy. So next will be the capacitors. I'm going to get a 3M socket for Agnes, then probably the ferrite beads, and then I will start to have a look at the semiconductors, some transistors, diodes, and so on. And then I will go berserk on the edge connectors, and I'll be well on the way by then. I need to pull a couple of these out of an old board because they're expensive and hard to find, and they won't match. I can get ones off an old board that match proper Foxconn stuff. You get the battery holder in, and there's still a lot of work to do, but I can see the end of the not semiconductors from here. Only just. I can just glimpse them on the horizon. Whereas when I started, I didn't know how it would work at all. With a bomb that lists the places things go, and with that component locator on the web, I think that this is in many ways one of the more doable electronics projects I've ever attempted, except for the fact that the scale of this is a bit on the extreme side. Anyway, I'll be back with capacitors at some stage. Can't say when.